Okay, so today we are going to continue on with the idea of factoring, but the factoring is going to get slightly more complex. So what happens is we're going to have some expressions that are trinomials, where the first term is not just x squared. This first term is 5x squared. So I'm going to show you a shortcut for this. We're also going to make a foldable Friday to help with this too. So you don't need to totally have this mastered, but I want to show some simpler ones. You're going to practice some of the simpler ones and some of the ones we did Monday to kind of round this out. So we're going to spend another day on this. So I'm going to give you a method for doing this, and there's a set of steps to follow. Step 1 is you multiply a times c. So in step 1, I'll show you that in a second, and then you make your diamond like we had in the last lesson. So I'm going to make my diamond. A times c is 10 for this one because a is 5, c is 2. So I'm going to put 10 at the top. I'm going to put 11 at the bottom. So it's a lot like the factoring we did before, right? It's very similar to start. And then we're going to factor. So I'm going to factor and say, I need numbers that multiply to be 10 and add to be 11. It's a fairly simple one, 10 and 1, okay? So I'm going to write this in the factored form like we had been doing. X plus 10, x plus 1. All right, and I want you to write that out. Step 4 is the sticky step, okay? This is the sticky step. You divide by a, which is 5, and then simplify. And I'm going to show you what to do with that. And I'm going to use a different color to illustrate this. So when I show dividing by a, I'm just going to divide the constants by a, okay? The first set of parentheses, I can simplify to be x plus 2, okay? X plus 2. The second set of parentheses, I cannot simplify. So the way I simplify this is the shortcut part. This is the part where you're going to have to kind of trust me. It's going to be 5x plus 1. And that's my factored form, okay? So this takes practice. This takes patience. Please take the practice seriously. Please be patient with me explaining this because it does take some time. So I'm going to move that ahead to the guided practice. And I actually just want you to do the first 3 steps, okay? So just do the first 3 steps of our steps. You don't have to do the final step. I'll show you the divide step. So pause the video. Just try to do part A, the first few steps of part A. And then I'll resume the video and show you how to do part B as well. So this is as far as I really want you to get right now. Multiply a by b, 6 times 5, to get 30. 30's on the top, 13's on the bottom, so numbers that multiply to be 30 and add to be 13. And then at the end, the divide step, you divide each of the constants by a. So the first set of expressions here, I can do 6 divided by 6 is 1, so x plus 1. And then the second one, I cannot simplify, so I multiply 6 on the front, and that's 6x plus 5. So again, right now I'm kind of just showing you a shortcut to factoring because guessing and checking can be very difficult. So that's why I'm showing you a method, right? A shortcut. So the factored form would be the x plus 1, 6x plus 5. In part B, it says in a trinomial, suppose AC is positive and B is negative. What do you know about the factors of AC? So if let's just say AC is positive. Let's say AC is 9, right? And let's say B is negative. Let's say B is negative 6. So that means numbers that multiply to be 9 and add to be negative 6. What do I know about the factors of AC? Each factor must be negative. And the reason each factor must be negative is because I'm trying to find 2 numbers that multiply to be 9, so they have to be the same sign. They either have to both be positive or both be negative. But I'm also trying to find numbers that add to be negative 6. So if I have 2 numbers that need to be the same sign, and they add to be a negative, they both have to be negative. And that's what we get into in the next problem, is some of these where the signs change. Not everything's positive. It gets a little more complex. So in example 2, our steps don't change. What we do doesn't change. We still do a times c. Now it's negative 45, and then the bottom number just stays the same. So we have to find numbers that multiply to be negative 45 and add to be 4. So I'm going to list out the factors of 45. 1 and 45. That doesn't work. 3 and 15. Doesn't work. 5 and 9. Now 5 and 9 would work because 9 minus 5 is 4. 9 times negative 5 is negative 45. So listing out the factors can help. That can help you brainstorm what you need to do. So to write this in the factored form, I'm going to do x plus 9 and x minus 5. And kind of like we did before, we're going to divide each of these by a, which is really, in this case, 3. So I can simplify the first expression, x plus 3. The second expression, I cannot simplify that fraction, so it becomes 3x minus 5. So that's the pattern. And it can get more complex as we go. So in the guided practice, I'm kind of a jerk. I give you too big of a number, all right? So in the guided practice, I can go through that with you just so we can be on the same page, okay? So the guided practice, I won't make you do on your own. Guided practice, if I multiply a by c, I'm going to get negative 140, which is a big number compared to what we've worked with so far. And I have to find numbers that multiply to be that and add to be 31. So I'm going to start listing out my factors. 1 and 140, 2 and 70. I don't think 140 divides by 3. Let's see if 140 divides by 4. Sure. 4 and 35. So I'm literally going to my calculator just doing, can I divide it by 2? Can I divide it by 3? Can I divide it by 4? And if you think about it critically, we can stop right here because 4 and 35 actually works. I can use positive 35 and negative 4 because 35 minus 4 is 31. 35 times negative 4 is negative 140. So my factors are plus 35 and minus 4. Now, there's a really important reason I picked this specific problem, okay? Because if I divide by a, if I divide by 10, you're going to recognize you can't really divide either of these evenly. So there's kind of a little bit of an intermediate step here to factor this completely. So what I'm going to do first is I'm going to simplify both of these fractions as much as I can. I can divide 35 and 10 both by 5. That becomes 7 over 2, okay? Excuse me. I can divide both 4 and 10 by 2. That becomes 2 over 5. So since those fractions are simplified as far as we can go, this is the step where I place those fractions out in the front. So you're always looking at when you divide by a, can you simplify the fraction? If you can simplify the fraction, simplify it. And if it doesn't come out to be a whole number, you put that denominator, that bottom number, out in the front. 2x plus 7. 5x minus 2. I would say this problem we just covered would be the hardest one because it had bigger numbers and it had a weird part of the steps that I talked about before. So I'm not expecting perfection on the first day. I'm expecting to kind of get the first few steps down and then start to see how that last step, how the pattern works in that last step. So back, and really I'm just going to focus on these types of factorings, to be honest. We can cover the other stuff Friday. So what I'd like you to do is go in and do the next activity in the lesson. That's going to help you kind of practice this and get the pattern down. Then do some practice, then do the checkpoint, and make sure you do it in that order. That's very, very, very important. Because if we don't do it in the right order, a lot of this stuff becomes a lot more confusing. And if you're still confused, don't worry. Friday, we will go over this stuff again. I'll make sure everybody's on the same page before we move forward. So move on to the next step in the lesson. It's a short activity to help you kind of practice this. I just want to move ahead. I really don't know if I want to cover example 3 yet, So I'm going to kind